Welcome. This is Chapter 17, Combined Gas Law. Pressure is caused by those particles hitting the container walls. If we have the same number of particles and we increase the volume, there are fewer particles hitting the wall per unit, and the number of collisions in one certain area will decrease, meaning the pressure will decrease. This is a way to say Boyle's law. The pressure and the volume are inversely proportional. That is, if I increase the pressure, the volume will decrease, or if I increase the volume, the pressure will decrease. We keep the number of particles, the moles, and the temperature constant. This is Boyle's law written as an equation. The volume and the pressure are inversely proportional, and K is a constant. What we are more concerned about is this form of Boyle's law. The initial pressure multiplied by the initial volume equals the final pressure multiplied by the final volume. This is a way to compare two separate situations for one gas. Looking at a graph, as the pressure increases, the volume decreases. This graph shows that it is an inverse relationship. Bicycle pump is a classic example of Boyle's law. As the handle is lifted up, the volume increases. The valve closes, you press down, and the volume decreases and the pressure increases and comes out the nozzle. If the volume of a gas is decreased, will the pressure also decrease? False. They have an inverse relationship. Boyle's law helps explain why our lungs work. In order for the air to enter, the pressure inside must be less so that it will flow in. As you breathe in, you are increasing the volume of the lungs. The pressure decreases and it pulls the air in. As the diaphragm relaxes, it goes up, decreasing the volume, causing the pressure to increase, and the air goes out. Another relationship is Charles' law. If we hold the number of moles and the pressure constant, and we look at then what's left, the volume and the temperature. They are directly proportional as shown by this equation. If the temperature goes up, the volume goes up. Again, K is a constant that you don't need to worry about. This is why we say that gases expand when they are heated. We increase the temperature and their volume increases. Why does the volume increase? The temperature increase means the energy of the gases has increased. The gases are moving faster, so they hit more often and with more force, and that pushes the container out. That explanation is based on the kinetic molecular theory. Again, we're looking at two sets of conditions for the same sample. We have volume 1 over temperature 1 equals volume 2 over temperature 2. This graph of temperature versus volume shows the direct relationship. Looking at this graph, you would assume that when we get to the origin, the volume of the gas is 0. This cannot happen, and so 0 Kelvin is thought to be the lowest possible temperature, which is absolute 0. Looking here, we have 0 degrees Celsius. We keep going, and the absolute 0 is negative 273 degrees. That is equal to 0 Kelvin. The relationship between Kelvin and Celsius is Celsius with the addition of 273 equals Kelvin. All calculations need to have Kelvin temperatures or you will get a negative volume, which is not possible. Looking at the various temperature scales, we have Fahrenheit, which is what we use here in the US. In the laboratory, we measure in Celsius, and for gas laws, we're going to use Kelvin. At 0 degrees Celsius, we have 273 Kelvin. At 100 degrees Celsius, we have 373 Kelvin. The difference is 100 for both of these. Notice that Kelvin does not use the degree symbol where Celsius does. Jacques Charles, who came up with these ideas, was a balloonist, and here is a drawing of the kind of balloon that he would have used. Here is a modern long-distance balloon. What happens when you heat a balloon or cool a balloon? And you can try this. Blow up a balloon, tie it off, and put it in the freezer. When you take it out, you're going to find that the balloon will be smaller because the particles are closer together. They don't have enough energy to press against the side of the wall. If the balloon is heated, the volume is going to increase because the particles are moving faster. They're going to hit the wall more often, and they're going to hit it with greater force, causing the balloon to swell. Standard temperature is 273 Kelvin. What is that in Celsius? That is 0 degrees Celsius. Check your answers against these. Many birds soar around using the hot air rising, and they don't need to use a lot of energy. Can you explain why hot air rises using Charles' law and the concept of density? As the temperature of the air increases, the particles are moving faster. This is going to increase the volume, and if we increase the volume, the density will decrease, allowing the air to rise. A car's engine makes use of gas laws. Gas is allowed in the chamber, and the spark plug initiates the reaction, produces gases which take up more space, and they push the piston down. As the gases cool, contracts, they let out the exhaust, and it starts over again. Gay-Lussac's law is keeping the number of moles constant and the volume constant, looking at the relationship between pressure and temperature. This is a direct relationship. If I increase temperature, the pressure will increase. The graph of temperature versus pressure shows this direct relationship. Comparing two sets of conditions for the same sample, put the pressure of initial over the temperature of the initial, pressure of final over the temperature of the final. If there is a flask with water at a low temperature, the particles have low kinetic energy. Recall that is the definition of temperature, the average kinetic energy. The particles that are a gas are hitting the sides of the wall, creating the pressure. Increasing the temperature of that gas allows more of the particles to be in gaseous form. They're hitting the walls more often and the force more often, so the pressure will be higher. In a car race, the pressure of the car tires is important. What do you think happens to the air pressure of a car tire over a long car race? Think about both friction and Gay-Lussac's law. The force of friction that's created between the tire and the racetrack increases the temperature of the tire. This increases the pressure. The variables that we talked about are all related. We have eliminated moles because that was constant in every situation. You must know the combined gas law. If you know the combined gas law, you, by default, know the other laws. Boyle's law is the relationship between pressure and volume. Charles' law is the relationship between volume and temperature. Gay-Lussac's law is the relationship between pressure and temperature. The units must be the same on both sides of the equation. If pressure is in atmospheres on one side, it needs to be on atmospheres on the other side. Volume, if it's milliliters, it needs to be milliliters on both sides. The temperature must always be Kelvin. Helium gas is given an initial volume, pressure, and temperature. The question is, what is the new temperature if we change the volume and the pressure? Identify the initial conditions, the pressure, the volume. Notice the temperature has been changed to Kelvin. Also identify the second set of conditions. Substitute those values into the combined gas law. The second temperature is the variable that we need to solve for. Using algebra, the second temperature is 604 Kelvin. Because the question asks for Celsius, I subtract 273 with a final answer of 330 degrees Celsius. This problem, again, is a gas that has two sets of conditions. The volumes are different. They will need to be converted. The pressures are different. They need to be converted. And the temperature, of course, will need to be changed to Kelvin. I chose to change the milliliters into liters and the millimeter mercury into atmospheres. You could have done the opposite, change the liters into milliliters. As long as the units are consistent on both sides, substitute the value in. Once again, we're looking for second temperature. Using algebra, temperature is 179 Kelvin. The question asks for temperature in degrees Celsius, so the value is negative 94 degrees Celsius. Pause the video and give this problem a try. I don't have all the variables. I have volume and temperature and temperature. There are several ways to do this. I could just take out the pressure, or I could put a 1 in for both pressures. Either way works. Substituting in, you need to solve for the second volume, 729 milliliters. Pause the video and give this problem a try. Notice that the temperature has been changed to Kelvin. Once again, this problem asks for a change in temperature. Solving for the variable, the temperature is 190 Kelvin. It doesn't say anything specific, so this answer would be acceptable. In chemistry, we like to use abbreviations. STP stands for standard temperature and pressure. and sometimes that will be given in a problem. Standard pressure is 1 atm. Standard temperature is 0 degrees Celsius or 273 Kelvin. Since we are doing gas problems, we will use 273 Kelvin. Pause the video and give this problem a try.